Good morning, good afternoon, or good evening, folks. Welcome to the latest Founder and Friends. Today, I am joined by my esteemed colleague, Dr. Panos Patros, who is a principal engineer at Raygun. Hi, Panos. How are you today?
Thanks for inviting me, JD. I'm doing good.
Yeah, well, it's a pleasure to have you on. A little bit of background on Panos. He's been working at Raygun now for almost a year. It's coming up that I can't believe how fast that time is flying. And Panos has
Yeah.
been leading a lot of the efforts around our APM product. We've got a few people working on that. And so today we're going to be having a little bit of a look into that, but not just purely at the Raygun side, aren't we? We're going to be looking a little bit more broadly about performance engineering, having a little bit of think about how we can use these sorts of tools. And I'm going to be honest. I thought, I've been building software for 30 years. I run a software company doing all of this sort of, telemetry and analysis. And Panos, you've raised the bar at Raygun. I really, really love having you on the team. And so I'm going to try and do as little amount of talking today to make sure we give everybody as much value as possible in our conversation. So I'd love it if you'd give yourself a little bit of an introduction. You've got quite an awesome story, and so I'll leave you to share it.
Thank you very much. Yeah. Well, awesome or unusual, I guess, given I've been all around the world, I guess. So I'm originally from Greece. I was born and raised in Athens, although my ancestry is from the Aegean Islands, Crete and the Dodecanese, which are small islands. Probably people might have heard them, maybe not. I did my undergrad in Greece in informatics and telecommunications. I worked there for 4 years as primarily a full stack developer, although the term was not that consolidated back then. But basically, I was doing PHP and MySQL and JavaScript, stuff like that. And I was also doing some university tutoring, private, on computer science courses. And then at some point, I decided that I wanted something more challenging. So I decided to go to Canada to challenge myself in terms of the temperature in places that reached minus 27 degrees centigrade. So that was great.
New
Apart from
Zealand is
that,
positively warm by comparison.
it's definitely warm. It's also, it's never cold, never hot here. It's a pleasant medium. Like it seems that it's all the time spring or all the time fall, depending on how you see it, something along these lines. But yeah, in Canada, I was lucky enough to find an excellent graduate program to work for. I went at the University of New Brunswick, which is in New Brunswick, which is one of the provinces of Canada. It's in the East Coast. It's close to Quebec and close to Maine, the U.S. state of Maine. And the city there is called Fredericton. I stayed there and I did both my master's and PhD under the same lab, the IBM Center for Advanced Studies Atlantic. And that was under a collaboration with IBM. And the main job there was to try to find ways to improve the performance of the IBM JVM and how to better utilize it within the IBM cloud. And near the end, because the IBM cloud was kind of decided to expand towards Kubernetes and Docker, we also shifted our attention towards that as well. That was, quite an interesting and fascinating work, and it was quite a big shift for me, having started doing PHP development to go into the world where we were actually making changes directly to the IBM JVM. And now, instead of just serving an end user or like a customer, we're suddenly serving a bunch of developers, which basically switches from doing software engineering as a method only to doing software engineering as a product, because now you're producing a software engineering product that is used by other software engineers.
Yep. It's something I've always found quite fulfilling in building Raygun, is kind of building software that our own team can use, that, we are in effect our own customers as well. And I tell you what, developers, we are a demanding bunch, and I think that's actually a good thing, drives up the
Yeah,
quality of the products.
exactly. And
And
it's
so,
this passion for software engineering, I think it's what kind of brought me back to industry, because there's a piece of the story that I haven't covered yet. So after I finished my PhD, I was very keen to become an academic back then, and I did make that happen. I was appointed at the University of Waikato, which is what brought me into New Zealand. And I stayed there for 4 years. At some point, I got promoted to a senior lecturer. I started as a lecturer. And I was also appointed at some point as the deputy head of software engineering. But at some point, this kind of itch of doing the actual software engineering versus talking about it kicked in, and I started looking for opportunities within New Zealand. And this is where I was able to run into Raygun, and I was beyond pleasantly surprised that I was able to find basically a company whose domain is not just in software engineering, but is in performance engineering for software engineering, which is a very niche area. And you would expect that something like that would not be easy to be found in a small country like New Zealand. But yet here it is, and there I am.
It's quite funny. We get we have quite a lot of customers around the world, and every now and then I'll bump into somebody in New Zealand, and they'll be like, "Raygun." And I was like, "Where are you guys based?" And I'll be like, "Wellington." They're like, "Wait, you're like 2 blocks over from our office." Like, no one believes we're here, but we are, of course, spread around the globe a little bit, but we are headquartered here in Wellington. So yeah, and like you, I have a passion for high performance software. Anything that makes the computer work better, I'm a big fan of. So we are delighted to have you on the team. And for those of you who maybe don't know, probably most of you, the New Zealand university system. The University of Waikato is one of our top comp sci schools. So being the deputy lead for the software engineering school, there is some no small feat. So that's awesome work there, Panos.
I was probably the person most interested in doing the management and administration of the academics, and this is why it ended up being. But I was also contributing a lot in the theoretical foundations of what it means to be doing software engineering, which allowed me to basically design the curriculum and say, look, you need to be teaching software requirements, you need to be teaching software design, you need to be teaching software testing. And you need to also ensure that the fundamentals of software engineering, like object-oriented programming, concurrent programming systems, are present. Yep. This has been kind of my main approach. So I was passionate enough for this, but it was also very close to my research interest as being very much focused on software engineering.
Yeah. And to that, before we started, folks, Panos said, whatever you do not ask me to talk about my PhD thesis. I will talk for hours. So we will jump forward a little bit here. What are some of the things you want to walk us through a bit today and talk about, Panos?
So the main goal here is to showcase a bit about how APM works. APM stands for Application Performance Monitoring, and it's one of the main 3 tools that we're offering here at Raygun. And what it does, and we've already kind of titled it as such, we're saying server-side monitoring, is it's providing a full picture of how a web request is being executed on the back end. So contemporary software engineering patterns basically necessitate that there is a client and there's a server, and the client makes a request, and this request is being processed by the server. And this entails a number of actions on the back end, as many of our, or most of our audience would be aware of. But basically, you start by a method that is a callback to capture this request and decide how to handle it. And this method will go ahead and perhaps call other methods, which will call other methods, which might spin up new threads, which might make external requests to either a database or an external API, wait for them, stitch back a response, and send it back to the customer. So APM is capable of being able to capture this life cycle of the request, as I like to say. And it's sometimes we refer to it as a profiling tool, but it's way more than a profiling tool because of the way that it can stitch up things and create causality relationships, that A happens after B, which happens after C, because one calls the other, essentially. Like in the more traditional ways of profiling mechanisms, because we do not necessarily care about a specific instance of the application, we're caring about its overall impact on performance. We have the concept of the old style statistical profilers. And this is not what APM does. A statistical profiler, which is the old idea, let's say, or the more traditional one, will interrupt the application at a certain rate, and it will decide what is the current stack trace, like where are we in terms of methods that have called other methods, and it will just create a histogram of all the possible combinations without any causality. And at the end, you'll end up with that method was called 50% of the times, that other method was called 35% of the times, and so on and so forth. That gives you a certain amount of information. And it would have been useful if all requests were the same, but each request is likely to trigger a completely different pathway, code pathway into our application. So if we really want to figure out what's happening on our back end for a specific web request, then we need to do tracing. It's not enough to do profiling, which is the old style, let's say, of doing things. Okay, we had a small accident here. I didn't put this up properly, apparently.
Hey, that's all right. Just on that point, and I'm sure some of the people in the audience have used like the JetBrains profilers, and I noticed that when I fire up that, and this is really for one-off, I'm doing some performance work, and they offer a range of options, and they kind of range from like low overhead, which is kind of, I think, more the statistical level stuff, through to like, hey, we're doing complete method by method, and they kind of warn you this is going to have a whole lot more overhead. If you're doing a really tight loop, maybe you don't need that yet. What's your sort of general thinking around the approaches for, is one better than the other, or are they just different use cases?
It's definitely different use cases. So I think if someone is running like a scientific application that you're expecting that more or less you have, if we think about it like an application that needs to start up once and needs to do a very big chunk of a calculation, it's like handling a single request. So you could take samples out of it and try to figure out what it does, because you're looking into a homogeneous, basically, sample set. But if we're trying to profile, let's say, an application, and at one time it's trying to do a read from the database, another time it's trying to do an update because you're dealing with completely different routes that behave completely differently, then you might take a lot of samples out of reading, no sample out of writing, but your biggest problem might be in writing, and you might not be able to discern one from the other. And this is where tracing will come along, and it will help distinguish what happens between the different types of requests that come into your system. Yes, if you turn up, for example, higher statistical profiling rate, you're going to be getting more samples, but you'll incur more overhead. Also, overall, doing tracing is a way more challenging system to implement. So this is likely to incur an even higher overhead. And I guess, this is the challenge that we have as engineers of this kind of performance engineering tools. We have to ensure that we make them good enough such that they do not incur significant overhead. So the analogy that I like giving here is we're making a thermometer, but we would make an awful thermometer if our thermometer gave fever to our patient. And this is the situation here. So yes, maybe, if from 36.6, which is the expected temperature, you're raising up to 36.65, it's okay. But if you're causing your patient to have 38 fever without your measurement, then this is not great. And hence, a lot of performance engineering work is actually required to make these performance engineering tools work properly. There's lots of self-referential work here, which is, in general, the cool thing about software engineering for software engineering, because you have to use software engineering in order to make good software engineering tools.
Yep, I've always loved the recursive nature of the software use at Raygun. Like as we continually work to be more successful, I kind of hope to one day be able to point partly to our own software as a reason that helped us be successful. And you're right. One of the things in talking with a lot of customers over the years, and it's something, a little bit of a design mantra for us, is the perpetual work to ensure that your performance monitoring tools have the lowest performance overhead. And the quote unquote joke that I used to make with people is, you don't want the biggest speed up you can make to your software to be removing the performance monitoring, which unfortunately for some of those older tools and whatnot, that was actually a huge speed up to stop looking at it, which is not great. So you have to do a lot of work to try and have something that's collecting a lot more data, but also not adding really any overhead or an imperceptible overhead for the user experience. That's a really hard tension to walk.
That is correct. And I mean, there are ways around it, because if you absolutely require something like that, you can use it during the development or during staging of the application. Like, because the idea is that, you don't just code in production. The idea is that you probably are developing in a local development environment, then you try it out on a staging environment, and then you move it into production. So something that perhaps is absolutely required but has a high overhead could still be employed on the development or on the staging/testing environment. But the important thing here, and especially the way that the world is nowadays, is to ensure that you have production monitoring. And I think this is another thing that distinguishes APM's goal. It could, of course, be applied for testing and development, and I would strongly encourage that everyone does this. But at the same time, we all need to ensure that we monitor our production systems, because these are the ones that will tell us the complete truth about what's happening. Regardless of how we can try theoretically in our tests to say that we have complete coverage, we do not. The way that we define coverage for a test is we're saying that, oh, the code reached this specific line. But in reality, this is a very much simplified abstraction, because if we see the complete idea of code coverage, it means that you have to have covered all the possible ways to reach to that line in order to have complete code coverage, which is impossible to happen really in reality. Hence, being able to perform this kind of adaptive monitoring, which can then inform the software evolution life cycle, I think it's critical to making successful software, and also increase the cadence with which we can produce next versions with high quality.
Yeah, and I know we'll have a little bit of a look at some Raygun specific APM concerns. One of the things when we were first building the product a few years ago, I'll just share as a quick story, was we got a lot of customers who loved the detail that we could provide, but, and this is the same at Raygun, is day to day, you don't need that much data to understand, is the system kind of performing within acceptable parameters. But when you maybe are having an issue, you want to be able to dial up things like sampling rates and data collection, because you may decide that you're actually willing to incur additional overhead because you're debugging or working on an issue in production. And so that's something where, if you've got a bunch of agents or things like that, you can control that through the web UI, and it will update those agents to change the rates that they're collecting data. And that was because we wanted to build a tool for ourselves that, as a software developer and I'm working on an issue, I just want to kind of punch it and go, collect me as much data as you can for the next 20 minutes, and pull that in. Because we heard that a lot from people saying, I have critical flows or critical paths that with sampling, I'm never going to get a sample out of this, and those sorts of challenges. So that's another area that we put a lot of thought into based on customer feedback early on how they wanted to work with these tools. And lastly, to your point about production as well, the way I write code and with Raygun, it's a very distributed system. But in dev, the entire distributed system runs on my local host. Turns out that runs pretty damn well, and especially when there's only one user of it. And so you might get some interesting insights, but it's not how the animal is working out there in the market with lots of users and fleets of servers doing stuff and network latencies and all of that. You're looking at a whole different beast.
Exactly. It's in the end, we're talking about a large engineering system, and we really need to start thinking software engineering as a proper engineering discipline. In the same way that we would not expect a factory to not have a bunch of sensors spread throughout all the critical points of its infrastructure and its processes, we should not be expecting a large software factory, because this is what we're dealing here, to be running without sensors. This is what Raygun is building. Raygun is building software sensors, and this is going beyond APM, because the other big products that we have, crash reporting and real user monitoring, they're also doing the same thing. They're just building sensors that the engineers can attach to their production system so that they can monitor what's going on. It's integral. If we do not have monitoring, we cannot really start a feedback loop to do reactive and proactive improvements to the system. And even worse, if you do not monitor the system properly, it might just come down crumbling, and you don't want anything like that.
The ones I used to hate is, and this is kind of a little bit of the thesis behind Raygun entirely, is I don't want the customer to have an issue that I'm unaware of, whether they tell me or not. I want to know the status of the system. Are we serving the customers well? And I think a lot of engineers, to be candid, often don't realize that this is it's about customer and user experience. Like, it's not uncommon to find engineers kind of go, I don't know how I affect the company. And it's like, you build the product, you make the thing that the customer uses. Like, you are the ultimate arbiter of the experience that they have, and these things are to improve the experience for them. So that's what I always want. Things are always going to go wrong, so it's like you're not really trying to say we get rid of anything ever failing, but we want to know what's failing.
This is bringing up, like, I think, an important topic. And for those who are interested, like, in research, I think the area of human developer factors is something that has been a bit under researched. Like, we're focusing a lot on HCI, but for an end user perspective. But we should be thinking that the developer is a special type of user, and we do require a completely different approach into understanding what their needs are.
Yeah, 100%. Sorry, I feel like I've derailed you slightly there in our in our chat.
I can be easily derailed into a variety of topics.
Panos and I can get chatting about stuff very easily at work. So, all right, that's all good. Where were we at?
We're talking about APM, and we have prepared a bit of a live demo to showcase.
Let's hope the demo gods are being generous today.
Yeah, exactly. So here's how our APM dashboard looks like. We have, so this is an application that I created a few hours ago, and as you can see, ensure that I tested it beforehand to be able to ensure that it's going to work. And you can see various things here. So we have on the top left an index, which is showing us how well this application is behaving. And the request execution speeds here, requests per minute, this is the throughput. So this is the response time, this is the throughput. And this is the how the requests are broken down into methods, API calls, and queries. Since this is an example application, not much is happening now, but we're gonna fire some load to it and see things appearing.
Yep. The other thing, sorry, I was just going to say for folks, if you already use Raygun APM, or if you're in Raygun and you thought about trying it, you'll see it's in the sidebar there. But this overview one is actually using our dashboard technology too. So if you're wondering like why there's all these different things, you can customize that and edit that and just kind of go, I want these particular blocks when I go into this app as well. So we just happen to give you all of the blocks.
Yeah, and overall, I would say that like response time and throughput are very standard metrics. So I think everyone should be considering including those two. And basically, the app index is a smart way to just translate how the throughput and response time is correlating into a single health metric. So these are definitely things that people should be considering including.
Yeah, there's a great Wikipedia page on AppDex as well. It's a kind of a joint industry standard for trying to aggregate and give you a top level sort of score for your overall performance.
Yeah, exactly.
Cool.
So let's switch to this amazing Node.js app that I developed.
I thought you said you were full stack. How's that CSS looking?
It has a zero CSS, but it has a bit of HTML because I have used the break tag in order to change lines here. Yeah, as I was telling you before the recording, I approached this with a computer science way of reductionism. So I'm trying to just remove any unnecessary noise and just focus on exactly what we need, which is the back end in this case. I'll show you the code afterwards.
Cool.
But let's try to fire a request at this. So I didn't even implement the link here, so we'll have to copy things. So I have this awesome route that will allow us to calculate an income tax. So we can, as you can see, I've tried it before.
Yep.
So let's say we throw 1,000 over there, and it's calculating an income tax for 2022, and it says it's 200, and it's rated at 20%. That's great. So what has happened now is we sent a request to the Node.js server, which is running on localhost. Doesn't matter. On this Node.js application, we have attached Raygun APM, and this is done straightforward by just adding require Raygun APM /HTTP. And you also need to install the appropriate NPM package. And then the system will capture all the methods that actually occur, and they result into this web request being executed, whatever methods it's called, etc. So now if we go back to our APM dashboard, we should be able to find this. So we can go to our traces and we can sort them by date. And as you can see, it's this one over here. This is a New Zealand time. So for those of you in North America, we're already in the future. So it's already June here. And as you can see, this is the method, the route
Request.
that we
Yep.
invoked. Yeah. And here you can see our flame chart, which is showing exactly what methods were called in order to be able to execute this request. So some of these things on the top, like request and parser on headers complete and app, these are the internal mechanics of Node.js. So it's good for you to know, especially if you're interested on how a language runtime works under the hood. But you're probably interested more into what your code does. Hence, you will have this in deep purple here, my code. So there's an anonymous Lambda function that it's called that acts like the handler of the web request for that specific route, which in turn called a method called calculate 2022 tax, which in turn called the method do work, which I added to just do a little bit of an iteration so that we have something substantial. Otherwise, doing a single multiplication would not have resulted into something substantial to show.
Yep. And just for folks at home watching this, I'm assuming you haven't put this code into a source code repository, but if this was your normal production code like we do with Raygun, if you would then click on some of those purple bars and you've connected it up to your source control system, it'll actually show you the code in the page of what that code is. Now, the reason I say that is like, these days I'm the CEO at Raygun. I don't do a whole lot of coding day to day. But what I actually love about this is I can jump in and look at a slow trace and click around, and because I can see that code right beside it, being an experienced developer, even if I'm not coding, can kind of get a pretty quick idea of like, is this just something really, really dumb, and like, oh, let's remove the thread.sleep, in here, or is this looking quite complicated? And that ability to very quickly sort of triage, is this going to be a 6-month re-architecture project, or is this going to be a 15-minute PR that suddenly makes it faster for everybody, is actually a really powerful combination to put a flame chart right beside the source code.
Exactly. And this is, again, the difference in thinking with like the human developer HCI mindset. Like, it's how can we really help the software engineer maximize the benefit out of using these tools. But yeah, for my next demo, I think I need to connect this into an actual repository so we can leverage the full potential of APM.
Yep, 100%. That'd be cool. I do find the flame chart view really handy. I know we can't see the URL bar here, but what's quite neat as well is if you were clicking on a method and you zoomed in and it was quite a complex sort of setup, is It's actually adjusting that data in the URL. So if you were then paste that link to a colleague, say in Slack or Teams, and they clicked on it, they're going to get this page exactly how you're looking at it. So, selecting the method, highlighting it, and helping share that context. That's another little example, I think, of that same concept you're talking about of how would a developer want to work. You don't want to send a link and then be like, now go find this, now click this, then zoom in over here. You just want it to appear as it appears to you.
Exactly.
Cool.
And I'll expand a bit the capabilities that APM has, or how it could be used, by showing you a slightly different example here. So let's say our developers were asked to create the next iteration for tax, and this time they were asked to make the 2023 tax. And what has happened is the government, in our case, has decided to increase the rate to 25%. But as you might be noticing here, even though I asked for income to be 1,000, the tax to be paid for 2023 is still 200. So this seems like a bug. It should not have been the case. So this is one of these cases that APM can also help us. So let's go and see what has actually happened. So we can go and try to find that request and see what kind of methods were being called, because that might give us some idea. Obviously, this is a completely artificial example because I made it. But so let's see. Calculate 2023 tax. JD, can you spot what might be wrong here by looking at the flame chart?
From looking at the flame chart, the app code, well, it's calling the wrong method.
It's calling the wrong method,
wrong year,
yes.
2022. Yep.
Exactly. So this is a very common bug that developers are making because they like copy pasting.
Yep.
So what has happened in this example, our fictional developers, they copy pasted exactly the same code that was handling the 2022 tax into the 2023 tax, but then they did not update the code as intended. So now I'm going to show you the code.
Is that a bug or a feature?
That's a very good discussion to have. Yeah. So let me show you the code here. Cool. Okay, so this is the main index one, but we also have the income route here.
Oh, some Notepad plus the IDE of the gods.
Exactly, yes. So you can see that this is the route for handling 2022 tax, and then the developers copied it over to make the 2023 tax, and they left over this method call to calculate 2022 tax, even though they did implement method calculate 2023 tax, but that's a common error to make, so they made that mistake. That's okay. So now we can go ahead and fix this error, and I will go and redeploy the application just to ensure this is working correctly. I'm not taking you into my terminal because it's going to take more time. The only thing that I did is just type node index.js. You're not missing out on anything. And I'll take you back to my tabs here so we can see again the APM application. And okay, let's first to make another request, and hopefully this will fix it. There you go. Now the answer is 250. So we fixed the bug. And to confirm, let's go and find this trace on APM. Let's go again to the traces. We can sort them by date as we did before. And we're finding the new one, calculate 2023 tax, that happened at 9:34, which is the time that I have now. And you can see now that we're invoking the correct method, calculate 2023 tax. So the reason I wanted to showcase this example is we're talking about this as application performance monitoring, but it's like the title, again, we're calling it server-side monitoring. It's not necessarily about performance. The way that APM works can reveal a variety of other things about our application, which could be used for a variety of use cases, one of which is just plain old debugging and functionality, and just checking that the code does exactly what it's intending to do. Because what we need to be remembering is that before we do code optimization and performance optimization, we first need to ensure that the code works correctly. So functionality first, and then performance, because like the fastest piece of code could be something that just immediately returns 0. There's no way to get a better speed up than by just doing return 0, but it's not correct. So it's not a useful speed up.
That actually, there's a story about that for a company here in Wellington, and they're a large business, and they had a legacy APM provider there. And I remember chatting to them. This was years ago, so I assume this has now been resolved. But they were like, "Oh yeah, we were all pretty excited because our app decks had improved markedly." And it wasn't until a little bit later that they realized that was because their 500 error page loaded really fast, and the system was down. It was like, oh, well, that's not a great alert then on that. So it does happen. And you're right, even what you're talking about there, our APM product, you can think of as monitoring the back end of your app. Real user monitoring as a term is about monitoring actual users of software, but in effect, that has largely become a category about monitoring the front end performance. And probably 10, 15 years ago, we might have installed an APM tool and gone, hey, this kind of gives us most of the visibility into performance. But obviously, one of the big changes in recent years is how much code we're stuffing into the client. So sometimes the back end can actually look quite fast these days, and that's where a RUM tool can hop in on the other end and go, yeah, but your users are still waiting 8 seconds for that page to react itself up, and that's slow. And that's something that people sometimes forget with modern software, because they may still have some tools in there to monitor the server. But we are seeing across our customer base the sort of sloshing of performance problems is just, it's getting all pushed out to the user. Similarly, kind of back to my point about me running, a distributed system on localhost. A lot of developers, when they're building these heavy front-end systems, don't fully appreciate that they're usually using a pretty high-end computer. They are loading it off localhost, everything's there, and it's actually a terrible customer experience, but it's great for them. And so getting that real insight about the users, and then of course our third product being crash reporting, what's blowing up and destroying the experience for people. But combined, it gives you a pretty complete picture. And so, for example, we won't demo this, but in RUM, if you're looking at a page load and you said, well, this took 8 seconds, of which 3 seconds was server time, if there is an associated trace in APM, you can click through. And so you can get that full visual of this user spent this much time with JavaScript on the front end, this much time on the back end. And to be honest, I don't know if I'm meant to answer these questions yet, but I'm going to bring one in here from Leandro. Sorry if I mispronounced your name there, and hi, Hastings.
One of my old students, hi, Leandro.
Cool. He wants to know if I have back-end code making queries to SQL Server, I assume any sort of database really, will it show me SQL metrics?
We do have an example for this, and since Leandro is bringing it up, let's go and...
it feels like a setup when it's a prior student.
Yeah. So let's go back because there's no... Whoops. Didn't hit the delete hard enough. I didn't set up any HTML to navigate here. But interestingly enough, I have this route here that will also show us a security discussion. Hence, it's called security, in case you're wondering. So this amazing request is counting the invocations that this request has been made to. So every time I refresh the page, this just increments this count invocations key and the value by 1. So if we go to our APM page again, let's see what we can find here. Yeah. Let's start again. So we're going to find our queries over here. And you can see that what we're actually doing is we're selecting and then we're incrementing the value by 1. So there's 2 SQL queries that have been associated with these web requests. So yeah, there's plenty of information that you can find here, including the amount of time, the distribution of response time that these SQL queries took.
And I'll just pause
we
you
can
here as well. Wait, just one
yeah.
second. A lot of people will know this, but I think it's really important. The median, the average, P99, P90. Averages are really quick to compute, and a lot of tools out there for monitoring love to talk about averages because they're very cheap. It's actually quite expensive to figure out like a P99 or a P90, particularly when there's a lot of data. So if you imagine if you had 200 million requests, which some of Raygun's customers absolutely do have, and you want to work out what's at the 1% end, you'd have to sort that entire set and then go and look at it. And that can use a lot of memory and all of that sort of stuff. So that's why a lot of vendors err towards the average. The thing is, there are times when averages make sense, but averages are fundamentally lies that we tell ourselves. And the reason I say that, I use the analogy of, Bill Gates walks into a Starbucks and on average, everybody in the Starbucks is a billionaire. And it's like, well, clearly that's not really representing the truth of the situation. And so we've at Raygun as a point of principle, you will find medians, P99s, and P90s because we didn't think it's great to give you a lousy number because it's hard work to give you an accurate number. And so you'll see that across our spread here. It's something I'll be honest, didn't really love statistics at university, but actually getting into this domain, building businesses and stuff like that, I found it super fascinating at how much even a little bit of statistical understanding will really shift how you look at these numbers to understand them. So I just want to draw attention to that because we do put a lot of work into trying to make sure that we give those sorts of insights across the board. Is this a real problem worth solving? Or is there like one timeout that made the average look like it was 10 seconds, but actually everybody's loading it in sub 100 milliseconds? That's a real problem with a lot of the tools that do this sort of reporting.
Yeah, and I should add to this that like in most cases, when there are SLAs that are being crafted, service level agreements, which contain SLIs and SLOs, service level indicators and objectives, they're normally described with this kind of percentiles because it's just very easy, as you said, to have outliers influence things. And the cool thing about these percentile metrics, and basically the median is also a P50. That's another way to think about it. It's also a percentile metric. Is that they can very easily exclude these weird outliers. And personally, when I was doing research for performance, we would always need to do this for the very simple reason that the garbage collector would kick in periodically, and something that might be normally taking a few milliseconds might end up taking a few hundred milliseconds. Especially, it might even go close to a second if like a big GC would occur. And this was completely unfair to be included into the results. So yes, always when you're looking into performance, you need to be looking into the 90th or the 99th percentile. And if you have SLAs, you have to look what kind of things you've promised. If it's the 99th or the 99.9, like 4 nines, 5 nines, this is the metrics that you need to be looking after to ensure that they match correctly. The average is very easy to skew things into the wrong direction.
Yeah, and to be fair, even some of that stuff in the older monitoring products, partly we are benefiting from the continual improvement in both smarter algorithms and more compute power to figure this stuff out. So it's not purely out of a lack of capability, but just also hardware. All right, we're getting the ping that question time is upcoming, Panos. So do we want to wrap on a couple of points here before we jump into any?
Well, I think I have one more thing to show to answer Leandra's question. So I have crafted a vulnerability on purpose into this app, and we can perform actually an SQL injection attack. And as you can see, we were able to extract a secret value from the system just by handcrafting a very simple SQL injection query here. And APM is also able to catch this. So if we go into our, again, queries, you can see that one of them has something weird here. So not only we were able to get the count invocations, which is what was intended, but due to the vulnerability into the code, you can see that a potentially malicious actor has been able to execute an SQL injection attack, and they were able to just extract a secret value out of our system. This is another kind of use case that I would like to highlight, that it's not just performance, not just functionality, but there's also security and auditing that APM can be used for. It's a variety of things. So don't think just about performance, think broader. And another angle that I find APM to be useful is concurrent programming has become really tough nowadays. And there's quite a bit of value in trying to understand how concurrent programming works. And APM can help with this as well, because you can see what we didn't show this here, but you can see that a thread can spawn another thread, and it can call other methods, and it can perhaps spawn other thread, and then they wrap up and down. So another usage here is just to help developers understand what they're making.
Yeah, I've found that super helpful. I'm more of a .NET coder, C# at my core. And, in recent years, we've had a lot more async handling, task this, dot result that, blah, 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 and as much as it's melted some brains at Raygun doing this, when we're profiling .NET apps, and you can kind of expand it out and see all of the separate threads and what they were actually doing. I kind of describe it as a developer, I have a logical model, and the APM product can show me the physical model, so that I can kind of go, oh, okay, that's what's happening here. And that can be super useful when you're trying to diagnose and debug. Like, concurrency bugs are hard because it can be very hard to recreate a scenario where the bug actually exists. So if you're capturing it as you go, it's super handy. We've got a couple of questions that have come through here, probably because I talked about this one earlier. We charge on traces. How do we do sampling, and when should I use it? So if you don't mind firing up your screen share again there, Panos, in the app, I'll just walk us through this one, since I talked about it before. So you'll see on the sidebar there under APM, we have sampling. And so if you click on this, couple of things here. So when we were building this and asking customers for some input, I mentioned earlier, they would say, well, we do get some form of sampling with other vendors, but if I've got a low frequency route, I'm never getting this. I'm never getting a trace. So that's why you'll see there that it's a sample one trace every minute per URL. So it's a bit web specific in general, but that's good, because if you've got something like a checkout page that, to be honest, I wish the checkout page was hit as much as the Amazon checkout page. But the reality is, for most businesses, it's going to be a less popular page than, say, the homepage. I actually would probably like to capture all of those traces. I want to understand my critical paths, that sort of thing. And so this has the option to adjust that. So you could say, I want 10 samples every 1 hour per URL. You can adjust that. What's nice about this is we do leverage an agent. We are, and we'll come to another question shortly, we're exploring some stuff there, but those agents will pick up the change from here automatically every few minutes. So that means if you are running a fleet, or you don't have to give somebody direct access to infrastructure to be adjusting this profiling in here. And like I said, the scenario that I tend to think of this with is setting a smart sort of default. We get a general idea of where performance is sitting. But hey, if we're working on an issue in a particular area, or we've got some problem, I can go in and adjust this and change it around, so I can collect a heck of a lot more data quite quickly. And you can see in there are overrides for particular URLs. So the view we've always had is, how do we empower a developer user to be able to just work the way they want? And so that's how this works. We do, like, say, we bill on a trace basis. So each time one comes through, it's a fraction of a penny, and the pricing is on our pricing page at raygun.com/pricing. Cool. Hopefully that covers a bit on the sampling.
Yeah.
Cool. So where do you see the APM space? Getting a bit of reverb there. Where do you see the APM space in 5 years, Panos?
5 years. It's
don't talk about the PhD.
I think a big change that we've seen coming up, especially this year, is the AI-assisted software engineering. And we have seen how much an AI assistant can empower software engineering. This is with very specialized tools that like Autopilot, but less specialized tools like ChatGPT. So again, these tools are meant to be used by human developers. And if human developers are about to change the way that they develop software, I think APM tools and every other software engineering tool is likely to require an adaptation such that it works alongside this new AI-assisted software engineering model, but also it looks into offering this kind of new AI assistant to be able to achieve these goals. This can go into multiple directions, and I guess people might have to stay tuned to find out what Raygun is coming up with this kind of thing.
Yeah, I will say we are quite actively exploring the AI space at Raygun. We did take a week recently to get the whole company playing with things. There is some super exciting stuff in there. Some of it is quite low hanging fruit too. Like not everything is a super challenge to get in there. So there's some cool stuff there. One thing I will say though, literally yesterday we dropped a fairly significant update to our APM lineup. So if you are a .NET developer, Ruby developer, or Node developer, we have full support for .NET Core, surprisingly even for .NET 8 Preview, which is kind of crazy. That's out there. I'd love you to give it a try and give us any feedback. The feedback really is super valuable. I know as software developers, we often like to play around with tools and we like to discover things ourselves, and we typically kind of don't want to interact with companies and people a whole lot. But we do have a link in the sidebar for contact Raygun there. And that we would just love to hear what you're loving, what you're finding challenging in there. But the changes we've just dropped are pretty awesome. This is another good question from your friend here. Personal information in SQL queries. Are we able to filter that, Panos? Oh, I think
working on this, and we are doing our best to obfuscate this kind of information.
Yeah, in general, for Raygun, this kind of goes back to some of the principles and ethos as well. Is we're heavily of the view around like compliance. We want to comply with whatever is out there. We also take the view that the data is your data as well. So that's not to say, hey, we shouldn't filter and be able to wipe data, but more to say, like, it is your data. That is the principle of which we operate under. And we even build features across the platform, acknowledging that people also make mistakes. So an example from crash reporting is that if you delete an error report in there, it does get permanently deleted. There's no soft deletes. We can't get it back for you if you remove it. And, quite honestly, the reason we did that is, more than a few developers, probably myself included here, every now and then inadvertently send data that they go, oh, that should not be going anywhere. Like maybe it's a session token or something like that. And so that's why we're designing our systems generally to say people do make mistakes. Let's have filtering. Back to that point about talking with people, we have an amazing customer success team to actually help onboard and do that sort of stuff to help people tune things up as well. So huge area, and I think it's just going to become a bigger and bigger area in the coming years as countries get a lot smarter about their data privacy laws. I've always said they're a bit of a hassle to implement, but as a consumer on the web, they're the right move. Nobody wants their data going everywhere. And we have one, he says it's a final question, but let's see if there's any more. Can Raygun trace calls to Azure Active Directory, like adding a user, updating email verification code, etc.?
I'm not aware of that, actually. We probably need to have our Azure specialist on call for this.
Yeah, I mean, to that end, I would also say it depends how you're calling it. So if your code was calling the Azure AD code, it would be captured by Raygun. If you mean I'm just using Azure AD and I would like to report metrics from it, that's not the way our APM works today. It's more about collecting and understanding the metrics of what the code itself is doing. However, part of that, we're 5 years from Raygun. The more metadata we can provide about the services where things are hosted, it just adds more context, and using recent sort of AI language, the bigger the context window we can give a developer, the more likely they are to be able to solve the problem. And so never say never. All right, we have one last one coming through. Panos, what is your biggest piece of advice for university students today studying comp sci and trying to decide what to do after school?
Okay. So my recommendation is try to get as soon as possible into an industrial position where you can gain experience and actually develop real software. Focus a lot while you're there on core software engineering courses or papers, whatever they're called, depending on the country. Like ensure that you're very strong in systems and object-oriented programming and around software engineering design and testing. These are the most important areas that can guarantee that you're going to get a good job afterwards. If you are interested for something further, I would recommend that you first take a bit of time to work in industry, like maybe 3 to 4 years before considering doing a master's. And if you have the capability, it will be a good idea to go to a different country to do your master's, such that you can gain a breadth of experience which can multiply your usefulness and how likely you are to be appreciated and climb faster the hierarchy. Probably you should not do a PhD as I did. The PhD is something that it's not likely to be a good investment for you. You're better off just by doing a master's, unless you're really, really keen and you have your own personal reasons. You can avoid it.
That's some awesome advice there, because we get a lot of these sorts of questions that come through. Raygun's a huge supporter of university students. We've hired quite a few over the years, and it is, transport ourselves back. It's sometimes hard to know what the right move is when you're earlier on. You're studying, particularly because universities are always trying to sell you on, why don't you stay at university forever?
To
So
just add a bit more on this, you should try to be responsible for your own education. That's quite crucial. Like, go ahead, take the extra effort and develop your skills on your own if you're seeing that it's not challenging enough. If it's too easy, it's not worth doing it. Remember this. And in the end, if you end up with a mediocre degree that you have a C on everything, this doesn't reflect anything on you. It shows that basically you did not learn anything at university, and this is something that will appear very quickly at your first interview. So just take the extra effort. Don't just try to pass through the system. And as my undergrad supervisor used to say, have the identity function applied on you, which basically is you came in Panos, you came out as Panos. Nothing changed. Like, try to avoid this.
That's a good way of putting it. We're going to wrap up here, folks. Thank you so much for coming. I'd really like to extend a huge thank you to Panos for joining me today. You do have a wealth of knowledge to share. I feel like we only just started scratching the surface on this topic. If folks would love to see a deeper dive at some point into more technical things, maybe there's a more focused show we could do together on that. And I'm also pleased to share some pretty exciting news that in 3 weeks' time, we'll be doing another Founder and Friends with a good friend of Raygun, Scott Hanselman, who many people will know in the .NET community as well. And so excited to have him on. Looking forward to discussing with him things around how he manages his time, his productivity, and I think the folks that know him, pretty in awe of everything that Scott achieves. So really enjoying doing these Founder and Friends. Thank you again, Panos. Thank you, everybody, for watching, whether it's live or later. Have a great rest of your day.
Thanks for inviting me, JD.
Awesome. See you, everybody.
See y'all.